this is 3.3, power functions and polynomial functions. So here's where we kind of get into like the pre-calculus stuff, because I think for the most part, a lot of it has probably been reviewed for most of you. So here's where a lot of the new stuff will come in. So we talked about polynomials. Here is basically what a general polynomial looks like. And I really want to talk about the first term. Okay, so looking at this guy. So this guy, this whole thing is what we call the leading term, because it's a leader. Okay, it's the one that's in the front. So it has the highest power. N is just basically the degree of this polynomial. And a sub n, this number is what we call the leading coefficient. Okay, so for example, if you had 2x cubed plus x squared, the degree of this polynomial is 3 because that's the highest power. The leading term is 2x cubed, and then the leading coefficient is just going to be 2. Okay, so we have this this information. Okay, now why is this important? Well, the leading term basically tells us a lot about the behavior of a function. So let me just write down right here the end behavior of power functions. Okay, so when we talk about behavior, we're basically saying what happens as x gets really big. Okay, and I mean this in the both positive and negative way. So if x gets really big negatively or positively, what exactly happens? Okay, so let's start off with the even functions, or like the ones with even powers. So let's look at f of x equals x squared, g of x equals x to the 4th power, h of x equals x to the 6th power. Let's see what happens when you have powers like that. And also later on, we'll take a look at what happens when you have powers that are with odd powers. Okay. So let's start off first with the evens. Okay, so what happens when we look at that? So what I'm going to do is I'm going to show you on Desmos, which is basically an online graphing calculator, what that kind of is. So let's start off with y equals x squared. So if you look at that, we kind of already know what happens. It's a parabola. You can see that as x gets really negative, you can kind of see that the y values, what happens to the y's, they get positive. Okay, because this is the positive y values. As x gets really positive, obviously my y values get really positive. Okay, so it seems that as x gets bigger in the negative direction and in the positive direction, you're always going to get positive y values. And that kind of makes sense, right? Because if you plug in that number in here, you're going to get a squared term, and then when you square a negative, you're just going to get a positive number. Okay, so what happens if I change this to a 4 now? Well, you still get a parabola. It's a little more flatter on the ends, but you can see that this is still going off to positive infinity. Okay, same thing if I were to do it to the 8th power. You get a flatter parabola, but it tends to go all the way to infinity, to positive infinity. Okay, so and this works well if you had another term like this. Okay, see how if I added another x squared term, this still goes up. If I added an x cubed term, it kind of does something weird on the bottom, but it still goes up. Okay, so what you can see is that it doesn't really matter what I put in here, as long as it's to a power. There's the leading term is to a power of an even number, then your end behavior is just going to go to positive infinity. Okay, so let me write that down. So the way that we write it is as x approaches negative infinity, the function approaches infinity. Okay? And also, as x goes to positive infinity, f of x goes to positive infinity. So this little arrow, one way that you can write it, what this means is as x approaches infinity. Okay, so this arrow just means approaches or it's going to infinity. Okay, so this is what we call end behavior. Okay, so this, whenever I say find the end behavior, this is basically what I want you to write down. Okay, so as x goes to negative infinity, f of x goes to positive infinity. As x goes to positive infinity, f of x goes to positive infinity. So this is saying that if I have something that looks like this, then what's going to happen is that you're going to get always something that goes upward like that. Okay. Now, what happens if I raise it to a power of an odd power? So if that happens, then let me change this to a 3. You can see that as x gets negative, what happens to all my y values? They start becoming more negative. And what happens if I make them positive? They start becoming more positive. Okay? If I change this to a 7, I get exactly the same thing, a flat thing here. Okay? Then this, as x's get negative, my y values also get negative. X values get positive, my y values also get positive. Okay, so what that says is that what will the end behavior be? So as x gets negative, my y values, my f of x also gets negative. And as x gets positive, my y values also get positive. Okay, so that is the end behavior for powers that are odd. Okay, so that's basically what it is. Okay, so you also want to keep in mind the transformations, because the transformations are also going to play a huge role in here. So for example, if I were to change the function, so let's say we wanted to find the function, let's say you wanted to find the end behavior for this. So let's say find end behavior. So let's first start off with one easy one, and then we'll do one that's a little harder. Okay, so notice that this is a parabola, right? It's a happy parabola. It's going to be pointing up. It's even also. So if it's even, so here's my even ones. Here's my odd ones. Okay, this is going to be the end behavior. So here what we're going to say is that as x approaches negative infinity, then my f of x is going to approach positive infinity. And as x approaches positive infinity, my f of x is going to approach positive infinity, which is basically what I have here, this guy. But what happens if I change it to this? If I say, now, what is the end behavior for negative x squared plus 2x? Okay, well now this is still a parabola, but it's now sad. So now it's going to kind of look like this. Okay, so what we say is as x goes to negative infinity, now what I did is I switched the y values. So my y values are not going to go positive infinity. Now they're going to go to negative infinity. Okay, and then as x goes to positive infinity, again, my y value has switched. This one's going to go to negative infinity. Okay, what about this one? Okay, so look at the leading coefficient. The leading coefficient is this guy. This is the leading term. The leading term is there. Okay, so notice that this guy is odd. Okay, so, and notice that there's no positive or negative, there's no flip. So that means this guy is this end behavior. Okay, so as x goes to negative infinity, this function is also going to go to negative infinity. And as x goes to positive infinity, f of x is going to go also to positive infinity. Okay? So that's the end behavior for that one. Now, what would happen if I change that to a negative? Well, if I change that, that means that my y values, this f of x, are all going to change. So as x goes to negative infinity, what's going to happen to my function now? It's going to change. It's not going to go to negative infinity. It's going to go to positive infinity. And as x goes to positive infinity, my f of x is not going to go to positive infinity anymore. It's going to go to negative infinity. Okay, so here you just have to be able to kind of understand what happens when you apply a negative, what happens if you apply a positive, or nothing changes. So really, the number, the leading coefficient doesn't matter. I could have had a 2 or whatever, the end behavior would have been the same. But when you apply a negative sign, that's when the y values are going to change. These, as x goes to whatever, it's always going to be positive and negative. What's going to be really what's really going to matter is the function. Where is the function going to? Is it going to positive? Is it going to negative? What's going on? Okay. So let's do another one. So let's say you had negative 3x squared, x minus 1, x plus 4. So something that looks like this. So a couple of things here. One of the things to kind of really consider is that what happens if I were to FOIL all this out? So one of the things that you can do is FOIL this thing out. What is this degree? The degree of this polynomial. Okay, the other ones were really easy to see. But now since everything is being multiplied, I'm not sure, is it 2? No, because if I FOIL all this out, what am I going to end up getting? Okay, so notice here, let's look at all the x's. You had an x squared, you had an x, and you had another x. That means when I FOIL all this out, what is this going to turn into? It's going to be an x squared, x cubed, x to the 4th power. So the degree here is 4. Okay, so the degree of this polynomial is going to be 4. So remember, 4 is even. That means it's going to be a happy parabola. However, there's a negative on the outside, which means that it's not going to be a happy parabola anymore. It's not going to be a sad parabola. Don't know what's going on the inside. Don't really care. I only care about what's happening on the ends. Okay? So what can we say? So we can say that as x goes to negative infinity, my function, okay, what happens to my function when it gets negative? It's going to go to negative infinity. And as x goes to positive infinity, so if I'm on the positive side, my f of x is going to go negative. Okay, so this will be the end behavior of this particular problem.